then this attacker breaks RSA. Okay, so that's what I mean. If an attacker can factor n, then this attacker breaks RSA. Why? So this is the proof. You see the public key. The public key is N and E. Okay, then this attacker, from this attacker, so the attacker can output P and Q from N. Why the attacker can output P and Q? Because we assume if an attacker can factor N, right? That's the assumption. Okay? If the attacker can output P and Q, then the attacker can compute phi n equal to P minus 1 times Q minus 1. And finally, the attacker can compute D equal to E inverse modulo phi n. In that case, you know D, that means you have breaks RSA. Okay? So that's how it works. How can the attacker compute E inverse modulo phi n? The attacker will use the extended Euclidean algorithm. Remember the extended Euclidean algorithm? Extended Euclidean algorithm is to compute the inverse. Okay, so the attacker, we need to assume here the attacker can output P and Q from N. That's the assumption. That's why the attacker can compute phi n. Okay, by doing phi n, then you compute T. So it's quite straightforward. Okay? So that means if someone can break RSA, as someone can factor n, then this person can break RSA. Okay? In fact, this particular attack actually is the same as the attack that if the attack, because what happened is like this. Okay, so forget about this assumption, for example. So what we do is like this. If we are just doing chosen plain text attack, right? So you can see that the public key is N and E, right? So if I'm the attacker, what I can do is like this. I will choose any M. I will choose M. And then what I will do is I will compute C is equal to M E modulo N. Okay? Assume that I cannot find the factorization, which is a normal attacker. Okay? And then from here, actually I can modify this one to something like this. C to the power of T will be equal to M to the power of E power of T modulo N. Okay, do you understand this one? So basically what I mean is I will take the left part and the right part to the power of T. Alright? So if I do like that, then I will get this equation. C to the power of T will be equal to M modulo N. Why? Because E times T is equal to 1, right? So now the issue now is, I choose M. My intention is I want to find D, the private key. So if I have this equation look like, I can do like this. I can do log C to the D equal to log M modulo M, and this is D log C equal to log M modulo M. That means D is equal to log M to the C modulo N, right? Okay, that means like this. Good. Okay, if there is no mod N, this equation is easy to solve. But if there is lock modulo n here, then this is the so-called, this is the discrete lock problem, which is a hard problem. So basically, this lock cannot be solved in polynomial time if it is modulo n. Okay, so that's why what I want to show you is, by just looking at the public key, you cannot compute the private key. So that because we need to satisfy that in RSA, we need to assess it based on the chosen plain text attack. This is precisely chosen plain text attack. I choose any message that I want, and I encrypt it. I want to get the private key back. But you can see that I will not be able to get private key back because of the discrete logarithm problem. So basically, this actually concludes concludes the issue that if someone can break the factorization, then this person in fact can break RSA. But there is no proof on the other way around. If someone can break RSA, then it's not necessary this person can break factorization. Nobody can prove this one. So, again, what I'm trying to say is, if I can break factorization, then I can break RSA. But if I can break RSA, it's not necessary that I can break factorization. So what I'm trying to say is, RSA problem is actually an easier problem compared to factorization problem. So if I can solve factorization, I can always solve RSA. But if I can solve RSA, it's not necessary that I can solve factorization. Okay? All right, so this is actually the proof for this one. So the next one is the attack that is important that you need to know is this particular attack. Right. So this attack is not